In this video, we're going to look at how to solve a quadratic with square roots. Before we do that, though, I'm going to discuss how a little refresher on how to simplify radicals. Okay. First of all, if you're not familiar with that term, a radical is your square root symbol. But it doesn't necessarily have to be a square root. It could be a cube root, a fourth root, something like that. We're going to be doing square roots here because it's quadratic. Now, you're going to have one of two cases when you're simplifying a radical. The first case is a perfect square. Okay. In this case, basically all you have to do is take the square root of the number. So for instance, square root of 49. Square root of 49, if you were not sure what it is and type in the calculator, you're just going to get 7. But actually it could be positive or negative 7, and that's what this symbol means. It's actually two numbers, positive 7 and negative 7. Another example, just to show you, square root of 100. Square root of 100, positive or negative 10. Because again, you can do 10 times 10 to get 100, or negative 10 times negative 10 to get 100. Now, let's say though that there was a coefficient in front. So 2 times the square root of 121. Well, that's 2 times the square root of 121, which is positive or negative 11. Which means I'm going to get either positive or negative 22. Okay. Case 2 are non-perfect squares, non-perfect square roots. Okay, what you have to do is, in the case of a non-perfect square root, is to break it down as far as you can go. So let's take let's take the square root of 112. 112 is not a perfect square. What you're going to do is you're going to break it down. So numbers that will multiply to be 112. Well, if you're not sure, there are little tricks that can help you out. For one thing, if it's even, it's divisible by 2. Okay, so if I divide by 2, I get 2, and 56. Okay, again, 56. Numbers that's divisible by. You can probably think of a couple, but I tend to choose the smallest one because it makes my factor tree a little bit neater. So the smallest one that I know is divisible or divides evenly into it is 2. It's 2 and 28. It's still even, so it's still divisible by 2. That's 2 and 14, which is 2 and 7. Now what you're going to be doing is you're going to be pairing them off. I got a pair of 2's here and a pair of 2's here. Because basically what I technically have here are square roots. The square root of 112 is equal to the square root of 2 times the square root of 56, square root of 2. They're all square roots. And the reason I'm pairing them off is because if I multiply the square root of 2 times square root of 2, what I'm going to get is just 2. So if I multiply these together, I've got a 2. If I multiply the square root of 2 times the square root of 2 here, I get 2. So basically, for each pair, you only pull out one of that number. And then the leftover stays under the square root. So what I get is plus or minus 4 square root of 7. If you have more than one thing left over, what you're going to do is you are going to multiply the leftovers together. So let me show you another example. Let's say we have 3 square root of 250. Again, 350 is not a perfect square. So 250, I'm going to break it down. And again, you can go by the smallest, which is what I'll do here, or maybe, okay, 250, that's 25 times 10. You can do it that way too. And this way, if you can figure out what the biggest perfect square that divides into the number is, it actually makes it a little bit easier, because square root of 25 is 5. Okay. Now, 5 and 5, I got a pair of 5s, so I can pull out a 5. But you cannot forget, if there's a coefficient, that coefficient doesn't go away. So I still have this 3. I'm pulling out a 5 from this, and I've got more than one thing left over. I have to multiply the leftovers together. Now technically this is plus or minus. I forgot that part. So when I multiply these together, I get plus or minus 15 square root of 10. Okay, so I wanted to do a quick review on simplifying radicals, because sometimes you are going to have to simplify radicals when solving quadratics with square roots method. Okay, now square root method can only be used if your equation is in the form of ax squared plus c equals 0. You can only do this if there is no b term, because what you do is you get it to where x squared is equal to a number, and then take the square root of both sides. Okay, so let's take a simple one for example. Let's take x squared minus 64 equals 0. So what you're going to do is you're going to start by isolating your x squared, which means I'm going to add 64 to both sides. This gives me x squared is equal to 64. Then you take the square root of both sides. 64 is a perfect square, so it's just positive or negative 8. That is my solution. So if you get a perfect square, that's all that there is to it. But what happens if it's not a perfect square? Well, let me show you one. So let's see, 5x squared plus 10 equals 310. Okay. So when you have one like this, you're going to start by isolating your x squared, which the first step in this one is going to be to subtract 10 from both sides. Give me 5x squared equals 300. Then you divide by 5. You get x squared is equal to 60. Once your x squared is by itself, you can take the square root. Now this one is not equal to a perfect square, so we have to break it down. 60 is 2 times 30, which is 2 times 15, which is 3 times 5. So, pair of 2's. So plus or minus, if you don't put this, it's wrong. So plus or minus 2 square root of 15. Alright. I think that's all I'm going to do for this one. Have a good one.